All right, today's aim is let's measure how quickly the output of a function changes. Right, the output usually is what we refer to as y. So if we're talking about the output changing, that's really talking about the change of y. All right, so 7.1, lesson 7, using graphs to find an average rate of change. All right, so we should know rate of change just means delta y over delta x, or the slope. But we're not always talking about a linear function, so that could refer to a quadratic's rate of change, a exponential's rate of change, not necessarily a slope. So 7.1, temperature drop. Here are the recorded temperatures at three different times on a winter evening. So they give 3 different times and the corresponding temperatures in degrees Fahrenheit. Tyler says that the temperature dropped faster between 4 p.m. and 6 p.m. Mai said that the temperature dropped faster between 6 p.m. and 10 p.m. Who do you agree with? Explain your reasoning. So you might think that the easiest way to tell would just be to find the difference between 25 and 17 and 17 and 8. However, the time difference between 4 p.m. and 6 p.m. is 2 hours, and the time difference between 6 p.m. and 10 p.m. is 4 hours, so we can't quite measure it that way. We have to actually calculate the rate of change. So let's do Tyler's first. So Tyler says between 4 p.m. and 6 p.m. So time, we know, is always our independent variable, or x, and in this case our dependent variable will be temperature. So if I want to find delta y over delta x, I want to stack my coordinates. So in this case it would be 4, 25, and then 6, 17. And I want to see what my change in y and my change in x are. So my change in x is plus 2. My change in y is down 8. All right, 25 minus 8 brings me to 17. So that change in y over change in x will be equal to negative 8 over 2, or negative 4. So what this means is that every hour the temperature drops 4 degrees Fahrenheit. All right, let's see if Mai has a faster rate of change, meaning that it would drop more than 4 degrees per hour. So we're going to stack his two coordinates from 6 p.m. to 10 p.m. So that'll be 6, 17, and 10, 8. All right, from 6 to 10, that's 4 hours. 7 to 8, that's down 9 degrees. So, right, you can always do 8 minus 17 to get negative 9. So my change in y over change in x, my y changed negative 9, my x changed 4, and that is equal, we could leave it as a fraction, but it's sort of difficult to compare 4 in this fraction. So that is equal to negative 2.25. So Tyler is correct. Because his rate of change is faster than mine. Dropping 4 degrees an hour is dropping faster than dropping 2¼ degrees, 2¼ degrees per hour. All right, that's all for 7.1.